Again, I'm going to record the session, so it's recording right now. So what we're going to do today, we are going to have a look at the topics of week 1. Well, we started week 0, so we're now in week 1. So we're going to have a look at the topics of week 1. But I would also like to discuss the homework briefly with you guys. And after last week, I kind of noticed it was a bit of a chaotic session. So I figured it would be better if I'm going to talk about the topic. And when I'm done talking about the topic, I'm going to take questions after that topic instead. So not in the meantime. So don't worry, I will probably see your question, but I'm going to discuss them after discussing the topic. So for example, right now I have some questions already, and I will get back on them at the end of the session if it's not relevant for now. So I want to have a bit more structure to the session. So let's see if this is gonna go better this way. So it's recording right now. So I would really like to see you guys. So if you would want to turn your video on, that'd be great. And we can actually kind of have the idea that we are in a meeting together. And again, I have prepared a PowerPoint. So let's start that and share my screen with you. Share screen. There we go. You should now be able to see my screen. Quick check. Are you able to see my screen? Good. Let's keep the chat open. 1 second. Click. Great. All right. So could you please let me know in the chat if you have done the homework? So then I know whether I can ask you some questions about the homework. So please let me know if you did the homework. Yes. Oh, that's really good. I get quite some yeses in already. So this week, we're just going to continue learning Java. That's the plan. And as I said, we are in week 1. Last week, we have had an introduction. We've seen classes, we've seen the basics of objects, packages, and we've seen some sort of class members. This week, we are going to go dive in the class member. So we're going to look at fields, primitives, and objects as well. They're actually not in the list. Way later, we'll see the methods. So for now, we're really going to focus on the fields. And we'll do some operations and casting. And you'll see what all of this is, so don't worry. We have an hour, we'll discuss it all. So since you all did the homework, let's reproduce it together. So the assignment was, if you remember, the assignment was to create the classes and the fields necessary to have a football tournament. So please let me know in the chat to everyone, if you are not shy, what classes you think you'll need for a football tournament. And I'm gonna go and head over to IntelliJ, and we're gonna do like 5 to 10 minutes to quickly reproduce the homework assignment together. So please go ahead in the chat and let me know what classes you'll need for a football tournament and what members are in each class. So I'm gonna go ahead and create a project for it. Class balls, I love that. I don't want to download, but sure, for now. Oh, class referee, nice. Stadiums, tournament. And did anyone divide any of this into packages? Because I would also really like to hear what packages you would suggest we are going to use for this. Yes, so what I'm going to do, I'm going to create the classes that I'm getting through that I agree with. So we have our main, we have our Java. So I'm going to create a package tournament. And I get class tournament. I see a class Team. Yeah, so I see some plural class names, so like balls and teams and players. It's the convention to always have the singular for the class name, so without the S, so that it's only one team, one player, etc. So you can have a class team and a class player. That's really good. And class game, yes. So a tournament consists of multiple games. Class score, yes, because you can actually make a score object out of it. So yes, that's nice actually. Let's do that. Score. Referee, that's good. Let's see, what more do we have? Team, player. Yeah, I think this is a good start. A trainer, we could have a trainer or a coach. I'm gonna leave it out for now, it's very specific, but that could definitely be a class as well. Oh, yes, so Bas, I think that maybe you should try to turn your sound on because everybody else is responding to what I'm saying. Let's see, let's write that to him because since he doesn't have sound, please turn your volume up. All right. So I have made a bunch of classes and let's see. What class members would these classes have? Let's start with tournament. What class members will tournament have? Could you please go ahead and type it in the chat for me? Team scores and winners scores, yes. And Raoul suggested we would make a score object. Oh, actually score is more for a game, I guess. Yeah, so we need some sort of teams. So since we didn't do any properties yet, I'm just gonna say teams. Yes, matches, pools. I'm not really sure how to write that, pools. Referee, I think a referee is not per tournament, but a referee is part of the game object again, because every game can have a different referee, theoretically. Or I'm not that familiar with football, to be honest. Team names, win, lose. Ah, yeah, so we'll have eventually we'll have a winner. So we can have a winner team. And then we have loser teams, clearly, because we'll probably have more than 2 teams in the tournaments. The football, yeah, well, we need a ball. Actually, I'm not gonna make a ball, to be honest, because it won't do a lot, I guess. I'll just assume it's there. But you could make a ball object if you have a certain purpose for that. Place, stadium, time. Time again, I think, well, yeah, it could be some sort of period or something. Place, yes. So this is enough for tournament, I would say. But this is good. This could all be fields for tournament. Then team. What does team have? A player, yes, or actually a list of players, I guess. Oh yeah, a name. It does have a name. We'll have some sort of coach, maybe. Oops. Okay. A ranking, yes, that's good. Color, sure. Supporters, yes, I'm not gonna leave them out. Yeah, so we'll have a goalkeeper, someone's saying. That's really good. But I think that the players could maybe have some sort of function, and that function could then be a role keeper. Number of tournaments played, yes, why not? Bench strength, I'm not really sure what it even means, but you guys are probably right. Anyways, let's move on, because we have quite some fields for team already. What could be in the score object? Timestamp, points. Oh yeah, timestamp. I'm not sure. At least points for each team, right? So points for home team and points for out team. Person who scored. Should it be in score? I think actually score is just fine if it just has two things, right? If it just has the points for the winner, for the home team and the points for the out team, I think that's enough for a score. The other things you are mentioning now, to me, it sounds more like the game fields, maybe. Oh, let's just go ahead and make a list of everyone who scored then. List of players that scored for home team. Because you guys really insist. List of players that scored for out team. All right? I mean, I'm not the expert here. So let's move on to the referee. What properties make up a referee? Yes, you need to name, or she, a country, probably. Yes, so these yellow and red cards, maybe number of yellow and red cards, something like that. Experience, years, age, well, it gets personal, but sure, you'll have an age, or actually better would be a year of birth, because then I can just calculate the age. What is a fine, Remco, or are you just saying it's fine like this? Boete. They get fines? I'm not sure about this. Yeah, I know, but I wasn't aware that was a referee kind of thing. You should explain me that after the course, maybe. So players, what properties would make a player object? I've seen one already earlier. It's a position in the field. Ah, yes, then we get the name, country, age. Yes, name. Oh, number on the shirt. Sure. Years of experience. Oh, total goals scored. That's fun. Maybe if it's a goalkeeper, you probably want to have some sort of, you know, average, right? How many he's avoided from being scored. Salary, sure. I think this is enough for now for the player. So I think I see, Remco. I was so confused. I wasn't sure what fines had to do with referees. So Remco just agreed with my way of implementing the yellow and red cards. Nice. So guys, what fields make up a game object? Rules, yes. Teams. So maybe a home team and an out team, because a game only has two teams, right? The ball, yes, I'm not gonna insert the ball, but the ball could definitely be an object. So you're saying referee name, Sauda, but I would go for just referee object in general. So I would just say some sort of referee. Year of invention of game. Place, well, the place I think was in the tournament class, so we can just assume that the game will be held at the place of the tournament. A time, yes, sure. And a date probably then. Stadium name, sure. Let's see what more. Maybe we want to keep the score? No? Score? Yeah, I think this is fine for now. So we have made 6 classes for our tournament. We have the top class tournament, who holds teams, matches, or well, let's rename them games since we called them games. Pools, winner team, loser teams, some sort of period in which the tournament is taking place, and at what place the tournament is taking place. So then we have the team, which has a bunch of properties too, list of players, name of the team, color of the team, etc. We wrote down some stuff for score objects. Then we made a referee object, which will give a name, country, number of experience, and how many reds and yellow cards they included. And then we have a player. The player has some sort of position in the field, a name, country, age, number on the shirt, and others. And we had a game which had rules, home team, out team, referee. Actually, I think the rules, they will probably be the same for all football games. So we could just leave these out for now, I guess. Yeah, and the score. Yeah, I think we covered most of the important things. Let's see, because yeah, so I have some questions now, which are actually quite good about the classes. And the question is that Dinesh is asking, can we only have one public class in a particular program? Well, we can only have one public class per file. So we have a file game here. That means that the public class of this file needs to be called game. So if I would rename this to something else, let's say, hi guys, something like this, it gets red. And if I hover over it, it will tell you why. It's saying hi guys is public, should be declared in a file named highguys.java. So it's very specific. It really needs to have the public class the same as the file name. So we have tournament here. And I'm having a question. I'm not really sure if we always have an upper class. We didn't discuss inheritance yet, so I'm not sure if that's what's being referred to, because, well, later we will actually see that there can be inheritance structures, but we haven't seen them yet, so don't worry too much about it. When you create a new project, you always create a new package. Yes, you want to avoid to have stuff in the root package, so you want to have your own package in there. So tournament is actually holding all the other objects. So that's a good observation from Danielle. Because tournament has teams and tournaments has games, and the games they have teams, and teams they'll have let's see, they'll have players, and the tournament has games, and the games they have a score, and the games have a referee. So it's all connected in a way. So that's a really good observation, and we'll also see that today how this is working. So something like this would have been a good way of doing the homework. Then again, there are many possibilities. If you've made an object for the ball, that doesn't mean you're wrong. And if you didn't make an object for score, that doesn't make you wrong either. If I want to switch to dark team, sure, I can go to dark team, or I can zoom in. That will probably also help. I suppose this is also helping, just zooming in. So let's move on to, let's go back to the presentation, and let's see something more about the Java field. So right now we have written just a bunch of comments in here, but this week you'll learn how to write fields instead in many cases, and also tell you how to handle the ones that you haven't seen yet. So let's move back to our presentation to see the Java fields. Well, what are Java fields? Java fields are actually variables inside the class. So when we have some sort of team, this team can have a name, and this name is actually a variable, because the next time we'll have a team, this team can have a different name. So it's a variable. And the second point is actually very important to understand the concept well. And this point is that a class has a relationship with a field. So a game has a score, and a team has players, and A tournament has games, and a game has a referee. So these fields, they have has a relationship with the class. And there's many types of fields. So we've seen it last week already very briefly, but you can have a specific type for a piece of text and another type for a number and yet another type for a decimal number. And what we'll see today is that fields can actually also be other classes that we've made ourselves. So for example, we just made the referee class. Well, a game has a referee, meaning that our new referee class can actually be a variable type inside another class itself. And yes, they also call this composition, I think. I personally don't use the term, but I think that is the right concept. So let's look at an example. Here we have a public class car on top, and this public class car has a color, which is of type text, and it has a number of doors, which is a round number, and it has a weight, which is a decimal number, and it also has an engine. And this engine, this doesn't really look like a standard Java object, does it now? Well, it's not, so that actually makes sense. Engine is an object I made myself, and since I don't know much about football, also not about cars, it's a very small class. It has a type of fuel, I figured that would make sense, and it has horsepower, which I thought should be an int, but maybe it should have been a double, I'm not sure. I just want to point out that your own custom object can be a variable inside another class, and this can actually go quite far. So with a tournament, and you're going to do that this week, which won't surprise you probably, but you're going to actually make quite a long chain. So a tournament has teams, and teams have players, and I don't know if players have something else, but you can make really long chains this way, and we're going to do that this week. So you'll really see, and if it helps you can even draw it to see the relationship between all the classes that you're having. I'm not sure if the players have a score. The game has a score, right? Or, well, I'm not sure, to be honest. Horsepower, I think that's a way of expressing how strong the engine of a car is. But then again, I'm not sure. I think it can also be called torque. Does that help? What's it called? Yeah, good. So these fields, they can be of any type, and I think it would be really good to dive a little bit more in the types that we can have in Java, so you'll see a little bit more about that. Are there any questions about Java fields in general for now? Nope, that's great. Then let's move on to the primitives. And if you still have questions, just post them and I'll check them afterwards. Is the text variable? Yes, so this type of fuel thing here, this is a piece of text and it's a variable. So the one engine can use gas and the other one could use electricity. Well, maybe that's not a type of fuel, but you get the point. And here the color, it's also a variable. So the one car can be pink and the other one could be, I don't know, gold, brown. What do you, behind that? What do you mean, Danielle, with behind that? A car has a color? Oh, you mean these pieces over here? Yeah, these are just comments. So everything with the // is just a comment. So the compiler isn't reading it. It's just a message for humans to know what's going on that line of code or those lines of code. Yes, a good question. So Java primitives. There are 8 Java primitives that we'll see today. Actually, there are just 8 primitives. You won't see any others later. But primitives are a very special type of field because they actually hold raw values, which means they only hold the raw value and nothing else. So on the slide, you'll see some examples. The first ones are byte, short, int, and long. And they are together on the slide for a reason, because what these do, they have something in common. They can only hold round numbers, so no decimals, and they can all hold negative values as well as positive values. But what you can see is that the byte, it's the smallest one. The short is already quite a bit bigger than the byte is. The int is, again, way bigger than the short is, and the long is way, way bigger than the int is. So logically, the long takes up way more memory, 64 bits, than a byte, which is only 8 bits. What is striking? Do you notice something that's striking between the min and the maxes on this slide? If you look at the min of all of those, what do you notice? Yes. The minus is one less. One is lost somewhere, Karina says. Anyone, any clue where that last one went? Yes, 0. Yes, and apparently 0 is more positive than negative according to Java, so it's it went in the positive numbers. And the reason, if you look at the bit is just a 0 or a 1. So if you have 1 bit, you can either have a 1 or a 0. So you have 2 options for this 1 bit. It can either be 0 or 1. So if you have 8 bits, you can have 8 times 2 options, which means that you always have an even number of options that you can deal with because you have 8 bits, and 8 bits, they just represent an even number of options. So this is why it's always an even number, but because it's an even number and you need a place for the 0, the maximums, they're always odd numbers. I hope that makes sense. If not, I also explained it in the video for this week, so you can have a look at that one too. So bytes is for small values, long is for really big values, and the standard one to pick is usually int or a long. Then 4 more primitives. We have float and double, which both hold decimal numbers, and float has a much smaller range than the double has. The float is 32 bits and the double is 64 bits. Fun fact about float, always have to postfix it with an F, because if you don't, it's considering it a double, and actually your code will not compile, but we'll see that in a bit. Then we have the char, and char is just for holding one single character. And this one single character is also translated to a number. So the minimum of char in numbers is 0. So it's unsigned, so to say. It doesn't have negative numbers. And I'm not really sure. I think the first 20 characters or something, they're all characters for white spaces. Then you have a bunch of other characters, and at some point they start with the A, and I think that was 97. But I'm not sure that it was 97. So if you say char C is A, and later you want to see what this A is in numbers, and you put it in an int, you'll see 97 probably. And then we have the last one, which is the Boolean, and the Boolean is just true or false, that's all. So it's a 1-bit value, since it has only 2 options, true or false. So those are primitives, and on my next slide, you'll see an example of how to create all these primitives. So the first time you are using a primitive, you also always have to, or actually any field, you always have to specify the type. So if I'm making a byte B, I'll have to say byte B is 10. I cannot use it if I didn't assign a value to it at first. So I can't just create it and then not assign a value to it and assume it's filled later. So it really needs to have this value assigned to it at some point before using it. And it's the same for all these types. So short, you just put short in front of there. Float is a float. Char is char. Mind the single quotes though for the char. If you put double quotes in it, it's looking at it as if it were a string and it will not compile. And then you can print them just like this. Like this. I could just say print B plus something something. And I'm having some questions. Leon is asking, do you need to know the conversion from char to number in your head? No, you don't need to know which character corresponds to what number. Dina is asking about big integer. Big integer is a special class Java made. It's not a primitive. So it's a class to hold a number, which is clearly bigger than a regular integer. And it's funky because I'm going to show a bunch of operations later, like just plus, minus, etc., with the plus and minus signs, and you cannot use it on big integer. It's for later, the big integer. It's actually not even part of the OCA knowledge, if I'm correct. Someone is asking me about this args over here. It stands for arguments, and you don't need to know this right now, but when you start Java, it always looks at public static void main first, and you can give it some extra arguments. And if you give it extra arguments, it's going to store them in this args string array. But again, we'll see it later. Let's see, what other question is there word size in Java? Well, you can do a count on the length of a string if that's what you mean, Sumet. I'm not sure if that's what you mean, to be honest. Does the long use decimal? No. So long is really a round number as well. So only float and double are decimal numbers in the range of the primitive numbers, that is. I'm going to ask you to play around with this for this week, so you'll get practice with it, don't worry. I want to move on to the next topic, which is casting. And casting, it can be quite complex at first. So casting is when you want to change the type of your variable. So say we have made a double value, and then later we want to store that double variable in an int. That's not going to work just like that, because Java looks at the double and it's like, oh gosh, this is more precise than the int is. I'm not going to be able to store this without losing precision, possibly. So if you want to do something like that, storing something that's bigger or more precise than something else, you actually have to do an explicit cast. Telling Java, I know this looks risky, but I know what I'm doing, so go ahead and do this. That's sort of what you are saying. So I always give this example of my kitchen, and that I have a bunch of containers in my kitchen. And sometimes I have this really big container, which can be full of rice or something. And when it gets below a certain point, it's just only half full. So when I have then a smaller container, I figure out, well, I can just, you know, push whatever is inside of there in the other one. That's fine. But I have to think and look at that. Like, okay, so is this going to fit? Because you cannot automatically assume that this content of this bigger container will fit in the smaller container. And that's the same with casting. If you want to fit something that could potentially be bigger than the other type, you have to do an explicit cast. So how do you do an explicit cast? Well, that's actually not that bad. You can just put between brackets in front of the variable that you want to change the type of what you want to cast it to. So we'll see it on the slide here. If you say int I is 3 and double D is I, that's fine, because the I is a smaller thing than the double. It's less precise. It can always fit into a double. But then if you want to put this double back into an int, it's going to tell us, nah, I'm not going to do that. This is dangerous. So what we have to do, we have to give it an explicit cast. And we're doing that here. So we're saying, change this D into an int and then assign it to J. So this is what's happening over here. So let's play around a bit in IntelliJ with this concept. Yes, so let's push this down a little bit. Let's start simple. So let's start with a double x, and double x equals 7.8. And now I'm going to make a float f, and I want to store x in there. Well, if we think back of this float and this double, float is only half the size of double. So you cannot inexplicitly put whatever is in double in float. So if you want to do that, you'll have to insert a cast. So let's insert a cast over here, and I'm just going to say float, and then it's fine. So fun question, or at least I think it's fun. Character A, and now I'm going to say int y equals ch. Is that going to be allowed? Please let me know in the chat. What do you think it's allowed if I type in ch right here? So I'm going to store char in A. Yes, quite some people know the answer. The answer is yes. You can do this actually. You can just store a character in integer, which might feel a bit weird. So let's see what this is printing, because I'm still not sure what it's 97 or 96. So let's have a look. Hold on, there it is. Oh, just kidding. I wanted to print Y clearly. There we go. Yes, that is correct. Yes, so it's 97, as you can see. So if we put the CH into an integer, it's printing out a number, and in this case, it's printing 97. So we have seen that char is 16 bits and int is 32 bits. So can we just assume that we can fit an int inside a char? Let me know in the chat, please. No, exactly, because the int, it's possibly bigger, and also it's signed, so it could be a negative number, and negative numbers will not fit inside the char. So even a byte I couldn't assign to a char without an explicit cast, because a byte could be minus 128, and the minimum of a char is only 0. So you'll have to do an explicit cast if that is what you want. So do I have a, yeah, so I have a double, yeah, I want an int. Okay, let's just make an extra int. That's 5. No, wait, you won't see 5. Let's go 103. So I can't say this because I can't just put the int in there. But if I make it a char, then it's going to say, oh yeah, but that's fine. And then I can print the char one. And if I do that, I can actually see what character that represents. It's probably 6th or 7th letter. Yeah, so it's a G, 7th letter, right? So that makes sense, right? Because then it's going to change this number into a character, and this character is the 103rd character is representing a G. So these are fun tricks we can do, right? We can just go ahead and cast it from the one value to the other. We'll see later that you can also do casting with your own custom objects, but that's not for today. Marek is asking, does the explicit cast work between any two types then? Well, it's a good question. So as you can see, I'm having a car over here. So if I would say something like car C2 equals, and then I'm going to say car in, this is not going to work. It says I cannot cast an int to car. So there are limits to that. So it should be logical for Java to do this casting thing. All right. Any questions about casting for now? Can we have multiple casts in the same statement? Yes, you can. You can make this really ugly if you like. At some point you'll see a syntax that will look, yeah, and I'm not even going to show it, but that's quite standard still, where you have 2 round brackets, then name of the whatever you want to cast it to, another round bracket, then a dot, no, yeah, then a dot, and then something something. No, I'm doing this the wrong way. Yeah, then the value, then the dot, then something something, and then the other round bracket. It's pretty ugly, but this is what it looks like often. So the casting, it can make your code a bit ugly at some point. So you want to avoid this as much as possible, but you'll find yourself needing it sometimes in some cases. Yes, as Leon saying, it's possible, please don't. You'll see that often. Yes, it's possible, but please don't. So that's casting, changing from the one type to the other. And yes, bus A is 97. It's I think it's the ASCII code character. If you look at the ASCII table, you'll see that it has the 97th position, which kind of makes sense that G is 103, because then you have B is 98, C is 99, etc. Can we cast a double or something like that into a Boolean? No, you cannot. It's like casting a car into an int. I'm having a bunch of operators I would like to discuss. And as you see on the slide, I called this slide Java Operators 1. And I called it Java Operators 1 because there are more operators than this. But for now, I'm not going to discuss 2 because I don't want to scare you guys all away. I'm really happy you are here in our second week, or also called week 1. And the other operators, you'll see them later or whenever you need them, actually. But for now, these are 4 types of operators that are really important and that you'll find yourself using soon enough. So the first one are the arithmetic operators. So these are just standard mathematical operations like plus, minus, divided by, times, and one or a few others. But those are the most important ones, and those are the arithmetic operators. Then you also have relational operators. And relational operators, they are comparing 2 parts. So they actually always give some sort of Boolean result. It's either true or false. Something is bigger than something else, or it's not. It's not maybe. It's always true or false. So you see some symbols on the slide. You have smaller than, bigger than, smaller than or equal to, bigger than or equal to. Then exclamation mark and equal sign means not equal to. And the double equal signs means equal to. If you use a single equal sign, you're actually assigning the value to a variable and you're not comparing it. Then we have the unary operator, and the unary operator, it's special. The unary operator is special because it only needs 1 variable. So this x plus plus, for example, means x equals x plus 1. And x minus minus means x equals x minus 1. So you have only 1 variable necessary to use the unary operator. Then we have the assignment operators, and there's quite a bunch of these. We have the equals one. This is the one we've seen a lot already. Int I is 5, assigning the value of 5 to I. Or double x equals 7.8, assigning 7.8 to or double x. But we have special ones. We also have plus equals. So what would that do? Well, if we have I plus equals 5, then it means wrap the original value of I, add 5 to that, and then assign this whole thing together to I. So if I was 5 already, and we say I plus equals 5, that means that we are going to assign 10 to I. Because 5 plus 5 equals 10, and then we assign it to I. And you also have it with divided equals. You have it with a lot of those. There's actually more than they're on the slide for now, but this is good enough. So let's look at a bunch of examples. There's quite some examples up here already. So in the first group on top, you see the arithmetic operators. We see plus, minus, times, and divided by. And I've used both variables and just hard-coded numbers to show that you can use it on both. You can actually also combine it. Then we have the relational operators. You see them. I smaller than j, I is equal to 9, or the last one, I doesn't equal 9. Then the unary operator, I plus plus, meaning I equals I plus 1. There's actually a subtle difference with plus plus y, plus plus I. And it actually has to do with the order. When there's a long statement and you have plus plus I or I plus plus, it's actually slightly different, but we don't need to discuss that right now just yet. It's a fun joke for later to see if I can confuse you or whether you really figured it out. Yes, someone's telling me prefix and postfix. Yes, it's fun. It's just very subtle difference in meaning. And then you have I plus equals 3. So it's just I, the current value of I plus 3. Yes, so these are the most important operators. Are there any questions about that? No, is it all clear? That's really good. Let's see if I can confuse you a little bit. When do you use unary? A lot, actually, Danielle. Later, you'll see a for loop, for example, and that's a place where you'll use it. So I have the integer here. So if I say in plus plus, or actually, yeah, this should be fine. This should print 104. It doesn't. Ha, I was doubting. So this is actually exactly where the difference between the prefix and the postfix is going to come in. So if I say this is going to print 104, it's going to say first add it, then give it back to this print line function. So now it's going to print 104. And if I do it the other way around, it's printing 103. It's first printing it, and then adding 1 to it. But we'll see later that in a for loop, you'll use the I++ all the time. Are there any questions about operators or something I can demonstrate using the operators? Always, Daniela says. So please ask, Danielle. So let's just give some examples here. Let's make an int. Oh, I have one of those already. Something with times equals and divided by equals to. So I'm just gonna get rid of this for now. And in here, I'm going to say we make an int x equals 6. And then here I'm gonna say x times equals 5. What do you think this will print? The value of x will be? 30. Yes, exactly. So I'll prove it later. So now if I say x divided equals 2, what do you think x will be? Oh, I'm getting some confused messages. So some people think 3 because I think they assume that x was still 6. But we really changed the value of x to 30 over here. So this is why it will actually print 15 instead. So it will print 15 and then it will print 30 and then it will print 15. Look. So let's do another one. We'll make a Boolean b and I say x equals 15. What will that print? True. Yes, really good. And if I say b equals x, well, bigger than 4, what will that print? True. Yes, it will print true as well. And then if I say b equals, see if I can confuse you a bit, plus x equals 16. Oh, what is print? True, yes. And what if I print b equals x plus equals 17? Yes, really good, guys. So let's prove this. True, 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 false. Because here it will be 17. So if I print x after this, oh, that's the fun thing. X will be 17. But it's not 17 at the point of comparison. So in here it's saying I'm first going to compare myself, I'm 16, to 17, and then the answer is false. And then when this is false already, I'm quickly gonna add 1 to myself and I'll be 17. But that can be quite confusing. It's fun, right? And then I saw a question from someone saying, I don't know how to read this. Well, I can imagine. So this is actually just saying x equals x times 5. Well, x equals 6. So 6 times 5 is 30. 30, assign that to x. So then here x is 30. What happens when you put square brackets around x plus plus? Yeah, I think then it might go first. Let's try. No, it still doesn't. It's ugly though. Any other questions? Because you're asking me some fun questions to look at the edge cases, which I always love. No more questions? Nope. Good. The last three ones. Yes, these three, I suppose. So what is happening here? Well, what this is doing over here, it's assigning something to b. B is a Boolean. And the value of x is 16 before we get here. We confirmed that because it says true to 16. But if you do x plus plus, that means that the operation to add 1 to x is going to be performed later. So it's first going to compare to 17, still being 16. So it's going to say 16 equals to 17. The answer is false because it's not. And then it's going to add 1 to x. X then becomes 17. So if you print out b, b is going to be false because at the time of comparison, x was still 16. But then before we are printing it, x will be 17 already. Good. Do I have all of you guys still on board yet? Yes, that's good. Oh, yes. And then Saurabh is asking a really good question, actually. He's saying, why is int I equals 5 divided by 4 not giving an error? Because we are downcasting here, right? Actually, we are not, because we have an operation with 2 ints, and it's just going to... I need to be careful, though. Let's just first try this. No, let's go int I. Do we have an I already? We don't, right? So int I is 4, int j equals 4. And then if I say int double k equals I divided by j. And let's see what this is printing. So I always mix this up. Yeah, so this is funny, yeah? Yes, it's gonna give 1. So what this is doing over here, 5 and 4, they are both integers. So the result of the integer divided by an integer is also going to be an integer. And then so first is an integer, and then after that it's going to change it back to a double. So it's going to add to 0.0. So it doesn't really matter if you do this or the other one, because the result of int divided by int is just going to be whatever the round number is, and then the decimal is going to be cut off. So even if it would have been 1.9, it would still have been 1 as an answer. Because it grabs these two, these are both ints. The result of the operation is also going to be int, and then there's no problem casting this to an int because it was an int. Does that help, Sarah? It's a bit funny, I admit that. Just show int diff because the operator helped. Good. So if you want to do that, you would actually have to make these guys doubles, or at least one of those guys double. And then I think it's going to be fine. Yes. See? Good question. Any other questions? Other way around. What do you mean, Raoul? Could you write it down in the chat? Double J. Yeah, that's the same. Because it's just going to promote it to the biggest operand. So if one of those is a double, it's going to make them both doubles, actually. Or it's going to make the result a double. Good question, though. All right. For this week, I have some assignment for you, just like last week. I'm going to put some YouTube videos on after this session, so in a minute. Under this YouTube video, I'll add a bunch of additional materials to study, so lots of blogs with more in-depth information on fields, operators, and objects also, and casting, and primitives. And then again, I'll give you some coding homework to do, which then we'll discuss again in our next week's session. Are there any questions for now? No? Yes, I will upload this session as soon as it's ready, and I'm gonna post some separate clips which contain lots of the things I already said, but just more focus on each topic. Oh yeah, so someone asked me whether I'm as good as developing Java as in data structures in general. No, I'm not. Java is more my thing than data structures, but you can't really do one without the other at the same time. So I know something about it as well. Well, thank you guys. I'm really happy that I saw you all back this week, and I really hope to see you all again next week, Saturday. Please watch the videos. If something is unclear to you, please post it on the video. And I read the comments this week. I will reply to them later. Wishing you all a very nice evening and see you next week. Thanks, guys. Bye-bye.